Hello, dear students. Welcome to our Engineering Graphics YouTube channel. So, students, in this session, we are going to start a new topic, and the name of topic is orthographic projection. So, friends, have you ever wondered how engineers turn a 3D objects into accurate 2D drawing? So, the process of conversion the object from three-dimensional into two-dimensional is called as orthographic projection. This is the important concept used in the engineering drawing. So in this video, we will learn what orthographic projection is, front view, top view, side view, the first angle projection method, and we will solve a simple example in step by step. So orthographic projection is a method of representing three-dimensional objects using multiple 2D views. Orthographic projection helps engineers and manufacturers to understand the objects clearly and accurately. So here, the object, whatever the object is there, it is a machine part or it is maybe made up from wooden or metal part. It is placed here. So this is the first quadrant, and this first quadrant consists of four different planes: front view plane, top view plane, side view plane. There are two side view planes. So here the front view shows height and length. The top view shows length and width. The side view shows width and height. So front view is usually most described view. It is drawn on the vertical plane. Front view normally drawn on the vertical plane for first angle method of projection. Top view is drawn on the horizontal plane. This is a horizontal plane. So the top view is drawn below the front view, and side view. So with the help of front view and top view, we can draw the left hand side view or right hand side view. So the first angle method of projection, in that object is placed, the object is placed in between observer and front view plane. Then we can draw the front view, top view and side view for this object. So this is a basic introduction for this topic. So we will solve a problem based on orthographic projection. Here you can see the pictorial view of an object is given. By using first angle method of projection, draw its front view, top view, and left hand side view. An observer is looking this object from this x direction. Now here, this object consists of the cylindrical part. This is part 1, this is part 2, this is the rib section, this is part 3, this is a part 4. So this object consists of four different parts. Observer is looking this object from x direction, and we know that when the observer is looking this object from x direction, so we get a front view. This is a, when you unfold it, when you unfold these all planes, so we get a multiple planes. Now you can see this is the front view plane. Rotate this top view plane along clockwise direction at 90 degree. Similarly, side view plane rotates at 90 degree. And here also there is one side view plane. This is also side view plane. These two planes are called as the principal planes. When you unfold all this plane, the front view plane position is fixed. Just unfold side view, this side view, this is a side view, and top view plane. So this is the front view plane, this is a side view plane, these two are the side view plane, this is top view plane. Now here in this problem, the front view is asked, draw front view, top view and left hand side view. So here, friends, if I'm looking, object is placed here. If I'm looking this object, this is my right side. So if you look this object from right side, so it's right hand side view we get on this side. So this is a right hand side view plane. And if you look this object from left side, this is a left hand side. So we get the view on the right hand side. This is a left hand side view. So these four planes, these four views are required for orthographic projection. Now, in this problem, the front view is asked, show the front view, draw the top view and left hand side view. So here you can see this is the front view plane position, this is the top view plane position, and this is a left hand side view position. We require these three views for this problem. Now we will see the solution of this problem. Before the solution, before drawing the front view, first read the drawing carefully. See the pictorial view carefully. Find the dimensions. Find the missing dimensions. Because we want a overall dimensions, the detailed dimensions for front view, top view and side view. Now here, we know that in the front view, or front view shows length and height. Top view shows, or top view gives length and depth. It is also called as width. And side view gives a box of dimension width by height. Now here, if I am looking this object from x direction, so this is a length of this object, this is a height of this object, and this is a width of this object. Now, from this end to this end is the total length of this object. And the total length, maximum length is 100. From this face, all these two faces are perpendicular to the base. From this face, center line to the central distance is 100 mm. 100 plus radius of the outer circle is 35. So total length is 135 mm. This is the length of this object. Width, total width, from this center, the bigger or outer cylinder diameter or radius is given, it is 35. So 35 into 2 is the 70 mm is the width of this object. So width is 70 mm. And height, from that you can see from this base to this flat surface height is 15 mm. 15 and flat surface to top surface height is given 50 mm. So 15 plus 15, it is 65 mm. So these are the overall dimensions, maximum dimensions for this object. Now we have already finalized a plane. So above, this is the xy, above xy we get a front view, below xy we get a top view, and in the right hand side view, we get a left hand side view. This is a vertical plane, this is a horizontal plane, and this is a principal plane. The principal plane is called as a side view plane. Now, see the solution. So first step is draw the horizontal XY line and draw the vertical XY line. Draw the perfect horizontal and vertical XY and X1 Y1 line. This is XY, this is X1 Y1. Now, for front view, top view, side view, draw the reference line above XY line, mark a 10 mm distance. This is another reference line. Similarly, on the right hand side and left hand side, mark a 10 mm distance, and rising thin line, draw another reference line. So this is a thin line. Similarly, adjust a ruler along XY and draw a line thin reference line at 10 mm distance. 135. Okay. This is X. Now, so for front view, top view, side view, we required this construction. So this is the main reference line XY and X1 Y1, and you can see the thin another reference line. Okay. Now friends, we can start this problem from any point, but here from this end to this end distance is 135. Total length is 135 mm. So from this point we can start this problem. Now here from this end point we can mark a 135 mm distance. This point is here. The height of this vertical line. Before that, see in the front view, we can see by using orange color, we can show the front view plane. In the front view plane, we can see this orange color section. Now you can see here. In the front view plane, if I am looking this object from its direction, so the orange dot plane is visible from the front view side. आणि हाच पार्ट आपल्याला ड्रॉ करायचा आहे. आपण ह्या पॉईंट पर्यंत रीच झालोय. इथून हाईट आहे, द हाईट ऑफ दिस वर्टिकल लाईन इज 45 mm. सो ड्रॉ द वर्टिकल लाईन from this point, and its height is 45 mm. Height is 45. Now here, this is a half circular part, and from this center to this distance is given. Now diameter from this end to this end, diameter is given 50 mm. So from this center to this point distance or radius is 25 mm. So we will draw the 25 mm line. Adjust the ruler along XY and draw a 25 mm line. Now total height of this half circular part is 45. 45 minus this 15. So the height of this plane surface to this surface is 30 mm. 45 minus 15. So 30 mm is the height. So we'll draw the vertical line. (30 mm) height, and the flat surface, this flat surface slab height is 15 mm and length is not given, so we can draw this, we can show this line with the help of thin line like that. Now the bigger cylindrical parts, its height is 50 plus 15, so 65 mm is the height. So we can draw this cylindrical section, and in the front view, the cylindrical parts looks like a rectangular section, and the rectangular dimension is, so diameter of the outer circle is 35 into 2, 70 mm by 50 rectangular part we can see. So draw the diameter of these. Draw the diameter. 70 mm is the diameter of that cylinder, and center point of this cylinder is at 35 mm. Now for cylindrical part, show the center line. For cylindrical section, show the center line. So by using dash and dot line, we can show the center line, and draw a 50 mm vertical line. This vertical line is up to this plane. So this is a plane surface. Join this line. This line is visible. Now this cylinder have a circular hole of diameter 40 mm, and as well as this inner circular hole have the keyway. The dimension of keyway is the width, and 5 mm is the length. Now we have already drawn a center line. So along the center line, mark at 10 mm and 10 mm distance. Now friends, this line, the small line, and this line is invisible in the front view. So first we'll draw the 20 mm distance along left side and right side, and the keyway, its length is 5 mm. So here all these lines, line number 1, line 2, line 3, are invisible from the front view, front side, from its direction. So with the help of hidden line, we can show these lines, and the circular hole is throughout. So this line is called as a hidden line. Now base is visible, so dark a base, as well as you can see this half circular part, it have the half circular hole, and its diameter is given 30 mm. So from this center, from this face, this circular part is not visible. So radius of that inner half circle is 15 mm. So from this face we will mark a distance, 15 mm distance, and from this point we will draw a hidden line. This part is, you can join this line. So this is a front view for this object. Now for top view, take a projection from front view. So already we have taken this projection. So take a projection from another face. So first, now you can see first, in the top view we get this green color section. The same surfaces appeared, the same plane surface appeared on the back side. So this surface also visible. This full plane surface is visible with keyway. Now here, the green color dot, it is a top view, and from top view we can see this full surface, green color surface. Now take a projection from front view. The total maximum width is 70 mm. So mark a 70 mm distance. This distance is 70 mm. Join these two endpoints by using thin line. Take a projection, center line projection, and find the center point of this top view. So center point we get at the 35 mm distance. This is center line. Now we will draw the circular part first. Now the center point of these two half circular parts are this one. So here center point is here. Now we'll take a distance. So this distance, it is a 15 mm distance in a compass, and from the center point we will draw a half circle. Similarly, this distance is 25 mm. Already this distance we have marked here. So take this distance in a compass and draw another half circle. By using this projection, from front view projection, we can also draw these circular part. You can see the front view and top view is perfectly aligned. So the top view, in the top view, the position of this part is correct. Now, okay, in the front view, this rib is missing. So directly we can join these two endpoints. So this is the rib section. In the front view, the rib part is missing. Over here, this is the complete front view. So directly we can join this endpoint. So we get this section here. Now we will draw the bigger circular part. Now here already we have drawn the center line. This is a thin line. After that we will convert this thin line into center line. So take radius distance 35 mm distance in a compass, or from this we can directly take this distance 35 mm distance, and we will draw a circle. This is outer circle. Then we can draw the whole of radius 20 mm. So take a 20 mm radius in compass. Take the same center and draw a circle of radius 20 mm. Now here, draw these two lines. These two edges are visible from the top. And here, these lines are attached to this half circular part and the full circular part by a tangent. So by the tangent, join these two lines. Now, show the center line. Draw the vertical center line. Now, we will draw the keyway part. The keyway part projection already we have marked here. So take a projection from front view and mark a 6 mm distance from both sides. 6 mm. This is a 6 mm, and draw the keyway part. This is the keyway part. Now show the rib section. In the top view, this slant surface is visible as a straight line, and its thickness is a 12 mm. So already I marked 12 mm distance here, so you can directly draw a 12 mm distance, 12 mm straight line. The rib connects the two circular parts, and this is a complete top view for this object. Now for side view, from this intersection of xy and x1y1, draw 45-degree angle. Draw 45-degree angle, and with the help of front view, and top view, we can draw a left hand side view. So for that, take a horizontal projection, and from top view, take a horizontal projection and project this distance vertically. So here we get a box of dimension, width and height. Now draw the center line. This object is symmetrical, so first we find a center line. So we know that this distance is 70 mm. So we get a center line is at 35 mm distance. This is center line. Now, friends, you can see from the left hand side, these parts are visible. The brown color sections, the brown color part is visible, and remaining parts are invisible. So the brown color parts are visible from the left hand side view. So these two rectangular strips, this circular part, these circular parts, this rib section, these parts are visible from the left hand side view. Now first we will draw these two parts. We know that the distance center to this distance is 15 mm. So we will draw the 15 mm distance. We mark a 15 mm distance from both sides. 15 mm, 15 mm, and the height is from side view, from front view, we can take a projection and we can mark a height from front view, take a projection. Also from top view we can take a projection, but from this view we can easily mark these two rectangular strip. So we have marked a 30 mm distance, and the thickness of this part is 50 minus 30, 20. So this is 10 mm. This is 10 mm. So you can mark a 10 mm distance from left side and right side. So this part is visible from the left side. So you can draw this part first. These two strips are visible, as well as this surface, circular surface is visible. You can see this full surface is visible. This bottom edge, this circular part, as well as this circular part is visible. The outer full circle is visible. The bigger circle, the cylindrical surface is visible. This full surface is visible. Its height is 50 plus 15, 65 by 70. This surface is. Now the rib section. The rib section is visible from this face to this face, and the thickness of the rib. This rib is visible from this face to this face. The dimension of rib is 6 mm left side and 6 mm right side. By using thick line, we can show the rib part. Now the keyway part. The keyway part is throughout, but here you can see here from this level to this level the keyway is invisible. So you can show this keyway as a hidden line. As well as this circular section, the circular hole of radius 20, it is invisible from the left hand side view. So from top view we can take a projection, or directly along the center line we can mark a 20 mm distance on the left side and on right side. The circular hole is top to bottom. So by using hidden line, show this circular hole. Now friends, you can see the solution. This is the front view, top view, and this is a left hand side view. Now here one line is missing. So the bottom surface, this surface intersect this circular cylinder by using a tangent. So from front view we have taken this projection and extend this line, and like that. So this is a merge section. This is the two parts merge at this point. So we have covered all these parts in the front view, top view, and side view. Now show the dimensions. This height is 45 mm. By using dimension line, show the dimension. This is 30. This is 30. This is 50. Then the distance, center to center distance is given here. This is a 100 mm. This distance is 100 mm. Radius, or you can show the diameter directly. Five 40, 570. In the rib, 12 mm. 5 mm. This is a 15 mm. Now here in the side view, this edge is visible. So here you can see this flat surface edge is missing. This is surface, this height is 15 mm, and from this to this height is 50 mm. This is 50 mm. The height already we have shown here, 5 mm. Okay, so this is a complete solution for this problem. So friends, try to solve this problem. If this video help you, give it a thumbs up, subscribe, and share it with your friends, classmates. Thanks for watching this video.